Welcome to another awesome session of the Eloquent Data. And a quick recap of what we did last week. So last week we started with data analytics with NumPy, and then I also introduced the community. So this week we'll continue with data analysis, but with pandas. And but before we start, Paul will take us through the discussion section. It's going to be structured into discussion and the practical section. So the discussion section, we're going to be discussing credit risk. So Paul, you do a little introduction. Just tell us what you do, your domain, and then you can start with the discussion.
Okay.
Over to you, Paul.
Okay. Yeah. Thank you very much. As I said earlier, as we met last week, I said my name was Paul Bananzi, and actually, what I did in school was accounting, but mostly when it comes to finance, we normally we then the finance students mostly during school we shared most of the courses, so I can say like it's interrelated.
Okay.
But actually, my specific this thing is mostly accounting, like there's the accounting aspect. But they are both interrelated. And so I think I was told by Solomon that I could share what I did on the credit risks. So I just wanted to give you an overview of what all the process that I took in order to come about and try to solve this problem that I. Hello.
Yeah, we can hear you.
Oh, okay. Yeah, so the first thing that one thing that actually I took, there were a lot of topics in my mind, and I was more like trying to get a topic that will actually be at least something that I will have knowledge about. So I think actually there are about three or four, and I sent them to Solomon to have a look, and finally I decided to uh, work on the credit risks. And one of the main reasons why I took it was looking at it, it was quite interesting, and mostly in places like mostly it deals with banks. And when basically credit risk is just talking about the risks actually involved in lending someone money or a credit facility. And we know that one main issue is that when it comes to banks and other financial institutions, when they're giving people money, is there's a lot of risks involved, and mostly so it's like you don't know whether the person will pay back or not. So it was quite an interesting topic for me to actually start and move on it. So uh, I actually took the time to before I started the coding and all that. I actually took the time to learn and actually get an overview or a theoretical overview of what the topic was actually about. So I learned, and I was actually so that when I was dealing with the data, I actually know what I'm actually doing, because sometimes when you get the data, you don't know what the topic is about. Sometimes it will be difficult to do any analysis on it. So actually, I was able to uh, go through some few topics and some terms, and just to get a deep understanding of what credit risk was about. So I started on it, and as I said earlier on, is basically about risks and how banks can reduce their risks by using data science and a machine learning model.
Okay.
So actually, I actually followed the steps involved in actually solving any machine learning problem. So I started with looking at the data and examining the data. So I did some data preparation or trying to make the data useful before you can apply any machine learning model on any data. You need to make sure that the data is somehow cleaned and at least is in a format that you can run the machine learning model on. So actually, I follow that steps. And when it comes to the credit risk modeling and with the data, actually, it's more like, well, I actually went through the process involved in solving the machine learning problem. So I started by examining the data and trying to make sure the data was in a format that would be able to run a machine learning model on it. So that was data cleaning and trying to work on missing values and basically one of the main problem about it was the missing values and missing values and actually trying to convert uh, most of the values in the data into categorical variables. And because of the nature of this problem, it's more like based on the research that I did and learned, mostly because it's about banks, and mostly banks are mostly the one of the key, let me say, key financial sector in any economy, because a lot of money is in everything. So mostly there are a lot of regulators that govern banks. So one of the main this in practice is that they always say that they always want the model to be you should be able to interpret the model, because if the bank is not designed to give someone a loan, at least you should be able to tell them what the model actually is, how the model actually works, even though you might maybe feed it information and maybe to tell you that, oh, this person has a higher probability of not paying back you a loan, but the model should be able to you should be able to explain to the person based on the model. So that's why I used a logistic regression, and based on the research I did on it, it's when you get the coefficients, you can actually interpret the coefficients. And as I said, we needed to convert all the values to categorical. So if anybody was numerical, I had to convert it to a categorical variable. So that was one thing that took most of my time. And at least I was able to, based on what I did, I was able to, when I look at the code, I was able to convert all the values into the categorical values in nature. And the other part was removing the features. And as I said, missing values was one of the challenges that I faced, because most of the values in the data were, some of the variables were missing, and some of them to about 70% of the values were, some of the columns, 70% of it were missing. So uh, I decided to even, because if I was trying to impute it, I would have found problems, because the number of values that were missing were very huge. So I removed them, and some columns were also irrelevant. So something like an ID column, and they're just identifying the customer. So they didn't really mean much. So I did everything, then the data was in a normal format. Then I ran the machine learning. As I said, I used logistic regression, and I ran the logistic regression model on it. But before that, the data was imbalanced. That is, in a normal scenario, the number of people that default, because in natural sense, we all know that the people that will not pay back a loan will be less than the people that will actually pay back. So in practice, the the number of people that defaulted were less. So if you run a machine learning model on it, it will be biased on one side, because it will see that most of the people that is on the data are actually people that have not defaulted. So it might favor one aspect. So maybe when you run the model on actual data, to make be biased by classifying everything as people that have not defaulted. So actually what I did is that I had to actually make sure that the data was somehow balanced. So I used the data was a random oversampling. So I randomly oversampled the class that was less to match up with the class that was what they call the class that's, let's say, the majority class. So I oversample the minority class to match the class that was in the majority. So that was what I actually did. So I did that. Then before I then matched, I then ran the regression model on the data. So I did the training, and then from the training I then went to the testing. And before that, I actually had to split data. And as you know, in every machine learning problem, you have to always split into training and tests. So I actually split the data into training and testing them. I use the training data set, but the oversampling, I did it only on the training set because if you do it, but that was the only thing that the machine learning model was always running. It's always run on the training set. So I did the oversampling on the training data. So after I did that, then I then applied it on the test data. So initially, I'll just describe maybe I faced challenges because I didn't. It's a process you do and it might not, and you have to go and start again. So initially, when I did it, I was getting a very low accuracy. And one of the things that I learned from all this was that when you are doing anything, the data that you actually work on, you need to have very good data and you need to have very good features. And because you don't have good data, you don't have good features, no matter any machine learning model you actually apply on, it will not give you what you need. So actually, I realized that one thing that made me realize from all of this is that actually you need to have good data, you need to have very good features. So one mistake that I did was that the correlation matrix, uh, mostly when two variables are correlated with each other, that means you can't put them in the same model because they provide the same information. Let me say two independent variables are correlated with each other. You don't put them in the same model because when they are highly correlated, let's say like 70%, 80% thereabouts, you don't put them in the same model. So I didn't actually. So when I was doing that, I removed. I had a chart where you don't take your time, you might be confused with it. So I made a mistake by removing some relevant features, thinking that I was removing features that were not important. So when I ran the model, I didn't get the accuracy that I was looking for. So I had to later had to actually go back and examine the table well. Then I realized that I removed some features that were actually important. So when I put them back and ran the model again, I had a very good accuracy. So it made me realize that the features that are in your data and the data that you actually use in solving your machine learning problem is actually important. And if you have very good data and very good features and all that, it can actually help you to solve the problem that you're actually trying to solve.
Thank
So
you
actually,
very much.
basically, that was the steps that I actually took to solve this problem.
Thank you very much for that. Was actually a wonderful. The article was actually nice, like a wonderful article. I remember when you called me and you told me you had a very low accuracy, and then you had to work on the data to improve it. That was brilliant. And there's a question I want to ask. I don't know if anybody has another question. There's one I want to ask. What metrics do you use for evaluation?
Okay. Actually, I use if you look, I don't want to put everything in there, but in the Jupyter notebook, I use this thing, the ROC curve, and I think I did a confusion matrix.
Okay, okay,
But the main metric that I used was the Gini coefficient.
okay. Thank you.
Uh,
I think
and
we should also we're going to have a class on data balance and also metrics. So add this to the
okay, okay.
list. But this is a very brilliant work, but we're kind of running out of time. I don't know if amazing if you have any question. Okay, okay. So in the absence of any question, I really want to thank Paul for this lecture. Paul, thank you very much. So
Yeah,
yeah, um we need to
Can you hear me?
oh yeah, I can hear you now. Oh, that means you muted before. Yeah.
Okay. Okay. Yeah, I wanted to ask. He made mention of the that having a good data is very important for any modeling to really give you efficiency, good efficiency or accuracy. Then I was like, okay, what was your source of data? That what was your source of data? Where did you get data from?
yeah, okay, okay. Thank you. Actually, it was on a platform called Kaggle, and I think it was a learning club, like a learning club. So what they do is that they give loans to individuals. So they actually posted their data sets online.
Okay.
Okay, thank you.
So I think Amaze already knows Cargo. So
Mm.
they kind of organize competitions for data scientists and machine learning engineers. So if you know you're very good, you go online, you go to the platform, participate in the competition, and then if you come out first, I don't know how they do it based on their awards. So if you come out top, you may get a reward for it. Zindi is something very similar to Cargo, but targeting the African audience. So you can check out the platforms. So right now we'll be switching over um, to the practical section. So I need to quickly open my notebook. Hope you guys had a wonder. Oh yeah, it's really amazing. Hope you had a wonderful time with the with Paul's article. It was quite insightful for me.
Yeah, same here. It was really, really wow. Yes, it was really, really amazing. Yes, I really enjoyed the article and I learned a lot from it too.
Yeah, cool.
Thank you, Paul.
Yeah, with that, it reminds me of part of the activities we'll be doing as a team. That will be writing articles on the monthly basis. So writing per article at least once a month, or one article a month, at least. So you can write more than one if you have time. But I'll just put in the range of one article per month. So it does two things for us. It's just like you teaching. So once you start writing your article, first and foremost, you have to learn the topic very well before you start writing anything. While you're writing, you're still learning the topic. And another thing, it brings you out to the public. So if people search for your profile, they'll see your article. Then you have you have little convincing to do. They already know what you're capable of doing. So on that note, I will be starting. I have to create